A world built on fantasy.
Most of these people are not ready to be unplugged.
We accept the reality of the world with which we're presented.
Existence could be beautiful or it could be ugly. But that's on you.
You want to build something.
You're going to build something.
Just need to build on it now.
I mean, look at all these people. They're free because of us. Because of what we did in this room.
G microchains, everybody, and welcome to our developer workshop. Hope you're still enjoying our kickoff build-a-thon dramatic cinematic video to get this thing started. We are now finished with the second wave of the build-a-thon, or rather the submissions, the second wave. We are now in the evaluation period. We are going to talk about that a little bit later. We're also going to go through some engineering updates on Linera side. Matthew's going to walk us through that. And then the majority of today's developer workshop is with our partners and our friends called Staex. Hi, guys. Welcome to the call. So glad that you're here. Alexandra.
Thank you. Hi.
Sergey, how are you?
Doing good. Thank you for this invitation. Super excited to drop in for the chat.
Wonderful. And Sergey and Max, welcome. Hi, guys. So great. So let's get started first with Matthew's engineering update, and then we'll talk about the build-a-thon, and then we'll go over into talking about Staex. So, Mr. Matthew, it is your
Hello,
show.
everybody. It's good to have you here. Hey, everybody. So, and thanks, Danny, for the introduction. I thought it's going to be very quick. Want to keep time for our guests and all the different topics. So very quick updates on our side. So we released. So last time we spoke about the new SDK. That's going to be a hard requirement very soon because it contains a fork that we're going to activate. So that was the 0.15.5. Since then, we released another one, 0.6, and there's a 0.7 with a number of fixes that you might be interested in if you work, especially if you work in the build-a-thon. And the 0.7 is coming next also with a few interesting improvements. So yeah, but the main message is like make sure that you have at least the one ending with 0.5. Because we're gonna, when you activate the fork, otherwise it's gonna break your app. What else can I say? We released some new puzzle for the Game of Life app. I hope you guys are having fun. There were a few more backend issues, unfortunately, with the scoring, the connection with the portal. That should be fixed now. And in any case, we create a workaround for people to be able to resubmit the puzzles, just to kind of like restart the process if anything went wrong. What else can I say? So we're still working on onboarding the external validators, and there was a DB migration also that is like still in progress, but that should not affect any users of the testnet. And excitingly, we started working on the demo on prediction markets. We've been talking about prediction markets a lot. And we hope to have some cool demo to show very soon. Other than that, yeah, the work on the main branch continues. Benchmarks are also still in progress, and in general, following the roadmap to mainnet. So that was my update. Yes.
Sweet.
Cool. Mm-hmm.
Thanks for the update. Let's go back to our presentation here. By the way, those new puzzles for Game of Life. Really hard puzzles, I think, go from being fun to not fun very quickly. I'm still trying, though. I'm still trying.
Oh, yeah? Oh, you're still working on it? Okay.
Yeah.
So one of them, okay, so I can give a clue. I mean, the extra hard one, you're going to need a little bit of help of the internet to find it, to find a solution.
Yeah. Open book. It's
good.
an open book test, is what you're saying.
No, it's just basically you have to ask yourself like how many cells can be live. So we're looking for a stable configuration. So in the rectangle of the board, we want to put cells in a way that they are like immortal, like the configuration stays the same forever. And the question is like how many cells can you pack into a given rectangle at most, right? With this property that the cells are going to be kind of immortal.
Right, I think we got to show people what you're saying here. So, okay. So what you're saying is, so this is high density. This is the expert.
Right. And so you gotta find a way to put as many cells as possible in there. So we're asking you to put, if you look at we want to have 30 cells live in there in this rectangle,
Right.
And it's kind of like the maximum possible. So you need to look in the internet how the hell you can pack that many cells in a rectangle, and it's kind of the sort of like the theoretical maximum, basically.
Generation 3. Got it.
All right, because like if you put them at random like this, they're not going to be immortal. Say they're going to die very soon, or you end up with like much fewer cells.
Right. Even just at.
So yeah, so there are like you can find on the internet. People have actually searched how we can pack cells into a rectangle like this.
All right, cell packing. Go search it out and find the answer. Okay.
Well, that's why it's hard.
Sorry?
That's why it's hard. So.
Yes, expert level, which I am clearly not. What else we got? We got the build-a-thon going on. As I mentioned, we just finished the build phase for wave 2, and we are now in the evaluation phase of phase 2. What are people building? Prediction markets, games, market infrastructure. It really falls into these 3 categories. In this second wave, I'll stay here. In the second wave, we had 53, James, is that right? 53 submissions, I think.
58 in total.
58 submissions. Yeah. So that's fantastic. Shout out to everybody who submitted submissions. We had put out a template for people to use so that it would be easy for us to kind of compile and run the applications. And some of you used the template. So thank you for the people who did use the template. That is good. James, anything you want to share at this point since you've begun the evaluation period first?
Yeah, let's see. So first and foremost, I think a lot of the submissions did not use the template. So thank you very much to those people who did. The people who didn't, be aware that we then have to judge based only on the... So we put out basically 2 requirements, either of which you could satisfy, either using the template or giving a live demo that uses the Linera client. There have been a lot of submissions that didn't do either of these things. So there were a couple that didn't provide a live demo at all and just did a source repo, or they have a live demo, but the live demo doesn't use testnet Conway. So either it tries to connect to a local node, which isn't going to work because I'm not running a local node service all the time, or they are purely mocked up. Unfortunately, I think we're going to have to disqualify those ones.
Yeah. Or they're just not going to win.
Yeah. For sure, yeah. They'll still be considered entries, but they're not going to win this one. Maybe next wave.
Yep. Cool. Well, we will continue to go through all of the submissions, especially those that actually compile and use the template. And please, the next slide that I wanted to share here was really about the developer role. So if you don't already have the developer role, which you can get at guild.xyz/Linera, if you meet these basic requirements, that is where you can ask questions about the product that you're building. Our engineering team is there. Other builders are there to help answer your questions. So it's really make sure you have the developer role. if you're working in the Build-a-thon. Cool. Linera.io/buildathon is how you get there. You should know that by now. And it is now time for us to bring our friends into the call. So Staex is building a decentralized, let me try, and you can tell me, Alexandra, if I've totally messed this up, but Staex is building a decentralized mesh for secure, coordinated, distributed systems. And Linera potentially helps to strengthen that architecture. So we're going to unpack Staex, look under the hood. Why is blockchain relevant to their model? And how does Linera fit into this design? So yeah, let's get started. I mean, should I just start with this question, Alexandra, or anybody? Like, what is Staex building? Or do you want to just jump right into your presentation to answer that question?
Yeah, let me first and foremost, thank you so much for inviting us. It's really cool. I like all the questions on the right side, so that's super cool for people being active. So just want to kind of activate even more. We're here to ask your questions, and thank you, Linera team. So I think we met quite some time ago. So I still need to say, right, it takes some time to actually come together and build something together. So also to everybody listening to, nothing happens like this in the industry, even though it's the fastest system we're talking about, right? So there are still people involved. And so, yeah, we're super happy to be here. We are Staex. We are based out of Berlin, Germany. And so let me, before I jump and show you a little bit of content, so that, the guests here also can visualize what is it that we're actually building. We have kind of, I guess maybe unusual structure for companies that are working in Web3. We're actually coming from an incumbent. So we've been actually the first blockchain lab around the globe, I remember, in the year of 2017. So Deutsche Telekom decided to invest into the blockchain topics, and we built the first, blockchain laboratory, actually. And so Staex was actually a product of a lot of research. We were part of DT lab for 3 years. And so I guess, it's our kind of specifics, looking into a variety of industrial automation, industrial machines projects, and seeing all of the problems, because we essentially build it along the industry. And so we ended up looking into how industry can actually profit from blockchains, and what is it all about. And essentially, we as a team, we've seen a lot of, bigger companies that wanted to do it like this. Well, guys, listen, I take my machines, I gather data in the cloud. And a lot of this data is still today, right? If you don't believe us, just go into the space and talk to the companies, right? It's still sent in the clear. Funny enough, right? So a lot of things are not actually encrypted because, for some companies, it's still kind of usability versus security topic. Somebody's like, who cares, et cetera, right? Something is just too expensive. And so they would take this data, and then out of this cloud environment, they would say, well, and then we push it into the blockchains, right? And so, us being there and kind of running this lab, we kind of thought, well, then it defeats the whole purpose of, I kind of want to anchor something, and it already went through like 10 cloud services. And so I'm not being dogmatic, right, and talking about like, well, you cannot do this. However, from the engineering perspective, when somebody comes and tells you, well, now you have to prove me that it's trusted data, I think it's almost impossible. Like, you have all these integrators in this kind of chain of events. So our kind of idea was, let's turn it around. And let's say we build the shortest trust chain. So we say, well, let's enable the device itself to actually sign the data and, put like a stamp on it. And then to put it on chain. So we kind of wanted to help the industry to access, different chains and be of help and of service to the industry to help them doing it at scale. And what we know from the industry, that's basically where Staex started building. At first we built like a complicated kind of blockchain, kind of aggregation service. And then we went into the industry and they said, well, are you joking? We actually cannot connect our devices. So even if we have this amazing blockchain service, a lot of transactions have been dropped. So what is it? Your immutability is helping us because help us with the first, line of problems. And so we essentially ended up building the network. And then we, addressed the problems up the stack, because then it was the question about, well, now how I actually update it, and, how do I update my machines, etc. And then, we finally ended up the industry requesting us blockchain. So we found the, I would say, highway lane for us, how the industry can actually use blockchains. Super proud of it, because it took us, I think, around 7 years. This is for trusted data, right? So for any type of data that the industry generates, be it CO2 consumption, production, passenger count, we're talking now about mobility industry, any type of data they have to actually prove to someone, like to the city or to their contractual partner, because this company sign contracts based on kilometers they drove. So you can imagine, if a customer or our partner, if a company, they have 100 buses, and you need kilometers they drove over the last 10 years, it's very complicated. Of course, it's possible, right? Manually, it's possible to do, but the amount of work that is going into this, it's insane. So if we can automate it and help them anchor it on chain, this is what we're building in a nutshell. And this all kind of connected to the operating system that you described. So how we can help. Essentially, it's not only about robots being on their own, but mostly companies that have these fleets to automate their fleets in a trusted way, so that we can actually go in and have control still over things that happened. So that's what we're building.
So I just want to unpack a few things that you said for everybody, just so we're all on the same page. So first, it's kind of, from the beginning, you were kind of thinking about this deep in, right, physical infrastructure, Internet of Things approach, right? Where when you talk about the devices,
exactly,
there's many different points of data that you're trying to collect from many different places and trying to kind of aggregate that in some sort of way, shape, or form, right?
Exactly. This is exactly where we started.
Yeah. And when you mention industry, you're talking about kind of Deutsche Telekom and the mobility industry. And can you just explain the industry again when you were kind of talking about that?
Right. So we've been working we started very broadly. The first thing we built, it was really inside a smart city environment, because they were interconnecting all the mobility sensors to get to build a dashboard where they can say, well, we have so many cars on the roads, we have, these buses, etc. So they were building a network across the city. Through this, we also started to work with charging manufacturers, like this new charging that build the chargers, right? And they want to grab data from the chargers, etc. And then we essentially just, ended up working for mobility, because all of a sudden we understood that bus is a huge robot. And providers.
Would you say buses are what?
Like a robot, right?
Oh, a giant robot. A bus is a giant robot. Got it.
Exactly.
Yeah.
And so, because we learned that the industry, basically every bus has cameras and sensors, and inside the bus, a lot of hidden sensors that we don't see for, whatever data points we get.
Definitely German buses here we're talking about, not necessarily all buses everywhere. Everybody's listening, they're like, that's not what my bus looks like.
What? And we see this, happening, will be happening more and more. For instance, also other markets. We're also active in Latin America, where they also started to how do we actually count passengers? It's also, very relevant information for cities. I also didn't know that. I didn't see this, right? In a bus, I was like, okay, that's just the bus.
Yeah.
Then they have insane amount of routing information, all the modules for controlling the safety, etc., etc. So we really love this vertical. All of a sudden, right? We were like, oh, that's actually interesting, and they have all the issues and problems that are, they need to solve it now. So that's when we we actually have something, and this is how we beautifully found this, fit from also what we are doing.
Amazing. So cool that they, going back to 2017 that they were already kind of incubating and trying to explore blockchain as a technology, and that it took years to kind of find the proper use case. I'm sure it's been an incredible journey.
Exactly. So, I mean, we started kind of as an R&D and then becoming independent. I think for us, it was super important step. Because I guess a lot of this kind of big corporate R&D work just, we stopped it because then you're as a startup and you're looking for verticals that you're working at. So it's been super amazing, and especially that we started with this kind of let's help companies access blockchains. And 2017, it was, great kind of talks and all that. However, essentially, when we went into real companies and like, okay, now you sign the contract and, we generate revenues. Everybody was like, well, it's actually nice to have. It's not something that we really need. And then it took us years to, really get to the roots of like, okay, what is it that where we can, help automate this, because also what we do with all this transaction generation, if you think it through, it's not only like we generate a bunch of data, but we also automate this, the way they can make the data trusted and verifiable and package it into certificates that they can just take it out of a system, in case, like for instance, some of the companies, they have to prove. We work with some cleaning companies, and they have a huge fleet of things, right? And they have to prove if an accident happens later on, like for instance, they clean snow or something. Also typical Berlin use case, maybe not for, guests
Los
from
Angeles,
countries, exactly. But they need to remove ice, right? And they have to have it as a proof in the database in case somebody falls down on this, like meter by meter piece of land. They actually have to go back into the system and have a verifiable proof that this has actually happened. And, guys, just from our estimation, the way you can do it in Web3 by putting transactions on Linera, right? You cannot compare to the cost that it would cost you in Web2, right? Again, it's still feasible. However, the whole infrastructure with audits, security around cloud environment, you as a business owner have to prove that none of your employees hacked into the system, changed the data, et cetera, right? So, and you just bypass all of it by, you just one signature, you put it on chain, it's there. If needed, you can. It's like a super trusted notary that cannot be bribed, hacked, and, and it's super powerful for the industry. Exactly. I also want to just comment on one of the questions on the mesh topic. So we essentially, it is
this question?
Exactly. We talk about virtual overlays. We are physically agnostic to whatever happens underneath. Because there is also like physical mesh networks. We are really doing an overlay because we went more for an overlay approach. Because we also learned that the industry, uses different tech. We mostly support mobile connections today because this is where our industry is coming from, and this is where like the most data drops happen. This is just wanted to weave it in while we're talking about it.
Great. Did you have some slides you wanted to share?
Yeah, let me just like visually also tell you a little bit where we're coming from.
And then we have another thoughtful question here after you pull that up.
So you should be able to see this now.
Great.
Exactly. So whatever we were describing, be it we worked for smart city gateways, charging stations, drones, right? It all falls now under the physical AI component. And basically by, starting with the network, because we think it's the heart of the system, going up the stack, we essentially are building the decentralized operating system. Funny joke, right? When we put this kind of into our pitch in 2017, the DOS was like, well, we're 30 years back again with Microsoft, DOS system. But anyway, so
funny.
Yeah, right. I was like, well, so it's for also, especially with the rise of AI, it becomes more and more important that I actually can identify my machine. Can also, on the other side, identify, which data we actually feed into the AI engine. And essentially, we wanted to, enable machines to be able to move value for certain reasons, because today, still what we see, it's all closed systems. So for companies that are generating the data, it's actually not possible to somehow monetize it and make sense out of it in the broader smart city environment. So, everybody still sits on their pile of data. And essentially what we know, it's only possible to, help them to monetize it through Web3, because otherwise it's just not working. Web2 never managed to actually build kind of cross-bridge systems. Also, a lot of AI engines now work with synthetic data. There are a lot of articles how amazing this is. However, there is still we feel the need for real world, and this is something that we can create. And we know that the industry creates an insane amount of data that can be exposed to the cities to make our cities smarter, to optimize the lanes of buses, etc., etc. And of course, that's where we're coming from. We've seen these integrations, like anytime any service has, is being built for machine applications, all these integrations are super, super expensive. For instance, if one company today shares data with the other company, maybe people don't know this on the line, but they still have to build a special integration between their two clouds, which costs 6 highly paid engineers 6 months at least. Because of all the rules and the things that can happen. So this is basically where we started, and we feel that the machines need this instant verified coordination across these networks, and this is how we help them with our stack. And so basically the thing is, we are an agent and software agent for. In our terms, Staex gives every device a very simple wallet. It's just a set of keys, because we think that for the industry, this is enough. And for a lot of low-end devices, they just cannot process more. And so basically, they can identify themselves. In the telco world, it's a super important topic. It's called AAA. It's authentication, accounting, and authorization. And so it's a huge thing. How do I actually identify a machine? And with the wallets, they can sign the data, right? So they become autonomous economic agents. They can send the data between each other. They can learn from each other in this bigger system. And of course, going even, next level, they can, what we already do, they can pull the data between themselves, using mobile connectivity, but also maybe in the future, also resources. But essentially, it all starts with kind of identification, right? So that we give every machine this opportunity. And what is, from our perspective, what is super new to the industry is that this identificator is actually the key, right? Because now the machine can do so much more on our behalf and do a lot of automation and verification in the system, what was not actually possible before. So this is a huge thing for us. Hopefully we're gonna onboard more and more verticals on the system that actually every device can do trusted communication. So we essentially enforce security by design, because today's internet, it's still optional for the guests, right? Internet has been built just to communicate. And then on top of this, we build some security protocols. And because they're optional, unfortunately, mistakes happen. And that's why there are so many attacks. Now a lot of clouds are offline. And this is actually because all of our devices are being misused to kind of attack, these banks. So this is a huge industrial issue. So that's what we're building. In a nutshell.
Cool. Slides complete. So, my first question is around what blockchain have you been using, or, you said, I think initially you said you were kind of building your own blockchain or your own execution layer. And so, what has been that process for you all along? And then, of course, you said that you have been in touch with Linera for a while. I'm curious to know about, how this relationship kind of developed.
Right. Thank you for this question. So how we started, I think, in 2017, there have been so many blockchains, and kind of our role of our lab was to actually, learn about all the technology and try to sell it back into the organization. And so, our thinking was like, it's kind of because we are, I'm super happy about financial applications, and I think that blockchain really found product market fit in for of course financial transactions. However, our knowledge of the team, we are all machines, industry, IoT, connectivity, right? And so we thought, well, building a blockchain without a real kind of use case in mind can be good. However, it's kind of you develop without the actual problem towards something. And well, we felt it's working for the industry. They always there is always an issue of vendor lock-in. Like I want to be able to flexibly use a lot of stuff, even if they don't do it. However, this kind of flexibility, because they all suffered through a lot of lock-ins in the past, because they used a lot of systems that they were not able to migrate from later on. So this is a huge topic. And then we knew about this networking problem and about this cloud problem that, let us help the industry not to put their data in the cloud. I think because, it's also saves resources and it's a beautiful solution. And we just said, well, we know networks, let's build the best industrial network, which is distributed, right? And well, even this, guys, was not so easy. I will tell you, it's kind of interesting journey. And so what we say, we use a lot of blockchain building blocks, because for me, blockchain consists of peer-to-peer layer, right? The nodes can talk, and then consensus that you are enabling how the transactions are being settled. And of course, like, the wallets, like how do you actually identify the nodes? And so we decided we just build the network, and through our network, because we know the industry, we know what they need, we can actually then connect to different blockchains. So we were never actually building a blockchain ourselves.
Right.
Staex is a network layer. We actually built our first one. Of course, we went to Ethereum. We their peer-to-peer stack is Leap peer-to-peer. This is based on Kademlia. This is the system how you route messages between the nodes. So of course, 2017 we got heavily inspired. We done our first implementation based on this paper. And tried a lot. This is like a pure peer-to-peer system. Tested a lot with this, closed our first contracts, and then learned that this peer-to-peer creates so much overhead.
Yeah.
And
you're talking about gas fees now, right?
We still don't talk about gas fees. But yeah, exactly.
That's the overhead, though. Is that what you mean? Yeah.
So
okay.
No, she means the networking overhead.
Exactly.
Okay.
It's also in messages that to find the peer, they have to communicate so much. And so connectivity is super expensive for machines. It's also another kind of thing that we're uncovering right now. And so we generated so much more connectivity. So they because the connectivity is being sold right now based on megabytes. And so every request is kind of, is really hurting, right? And so we ended up actually rebuilding our stack, making it more close to how DNS is working today. So it's a combination of kind of centralized and decentralized architecture. We call it pancake routing that we're currently using at Staex. And so this is actually our specialty. And even in this little component of network, there were so many kind of learnings, and what we rebuilt and made it more efficient and rewrote it. And we started with Go. Now we write our code completely in Rust. So we also care about latency. And so yeah, this is what we built. And we said, now working with Linera, you have an amazing team, amazing tech. Typically it requires a bunch of mathematicians, and smart coders to create any type of, consensus and, resistant network. And so we just said, well, we're going to partner with smart guys like you and help industry to actually kind of explain in the terms that we know they understand. What is it actually the value? Like, for instance, now we can say, well, every bus has its own chain, right? And it's very simple for the industry. And this is what we're doing. What is important to us is that we go away from this approach. I first put my data into the cloud to I actually just sign it on the bus, and I even don't need the cloud. And this is kind of super, fresh wind also for the industry, because when they like, oh wow, the whole infrastructure is actually there. I don't have to like set up complicated cloud services, etc. And that was kind of our initial thinking. Like, for machines, you don't really need so much as we need for, of course, AI and all this kind of more centralized big data applications.
Yep. I feel like this, Matthew, I want to bring you in, but I do want to share this slide because I think that this will be, where'd it go? Here it is. Because I think this will help to crystallize a little bit. So actually, do you want to explain, because we've been talking about the busing, the data flow, the buses, the blockchain routing, kind of, I think this now begins to create a visual explanation for what you're describing and how it relates to Linera.
Exactly. And what I can add on before Matthew just stealing his word is just from our side, it's also interesting because like every chain, because like every bus uses the chain, has a more simplified consensus to speed up the transaction writing speed. We think that it's a perfect combination between Staex and Linera because we make the data trusted, so we can prove at any given time and moment that that's exactly this bus at this exact timestamp. And then I think in combination it makes like a super future bulletproof, not even future, it's actually running on the roads now, but like a bulletproof system where we have no garbage in, garbage out problem. We have crazy amount of transactions, and basically also actually if you think it through, because we also will be building the experiences for the industry where they're going to manage these transactions, right? And now that it's more structured, like every bus has its own chain, it's also easier for us to kind of showcase it for them on their end, because it's more structured from that perspective.
Matthew, want to bring you in. First of all, if you have any kind of feedback or
comments on what we're very happy to work with Staex. Since I started discussions, I found that the use case was like really playing the strength of Linera, and so we've been very happy to work on this because and in general that's why also I'm always very excited about DeepIn or Linera, because the DeepIn systems are naturally parallel. You have a number of devices that are running usually mostly independently, and Linera, we are a highly parallel infrastructure. Like by construction, we don't force users to send transactions on a single chain, so we don't create artificial contention between the different workflows of users. We in fact allow users to have their dedicated blockchain, so in the form of what we call a microchain, and so that gives you this very natural mapping between like one bus, one microchain, and it doesn't matter how many buses you have, each of them is going to be able to post data anytime. So in the case of Staex, for instance, we talked about like having like what it would take to have the guarantee that if you want to post every second, it always works. Like every second you post a block that it takes maybe like 200 milliseconds or like maybe 400 milliseconds, but you can always, it's like clockwork. That kind of guarantees can only be provided when the underlying infrastructure is parallel. It's not creating contention between the users. And so yeah, there's a unique fit. So it's really cool to see applications using it.
Yeah, and
Not to
I'm always
mention-
excited. Sorry, keep going.
Yeah, and so not to mention also, in this particular case, the motivation is the data traceability. So another problem of blockchain, of traditional blockchain. So not only they force all the users to use a single chain of blocks, so creating contention, but it's actually pretty hard to read data from a normal blockchain. You always end up trusting a third party for running a full node for you and kind of indexing the data and telling what's going on the blockchain. And so that's something that also down the road, I hope is going to make a difference. The way anybody can, if you, as a user, if I want to know what are the datas, which data has been posted by this particular bus, I can run I can run a Linera client essentially, and I only need to download a very limited amount of data, and I will be able to replay them trustlessly locally, and then verify the data, verify the chaining, verify everything, and consume and then read the data once they have been replicated locally. So we have one of the only systems out there that we call it's called a sparse client. So you basically, when it comes to interacting with Linera and reading data from Linera, you have the security of a full node, what's called a full node in normal system. You have the security of a valid, like basically the same security as if you were reading a validator node, or but you only need to replicate a fraction of the data. So not only we have this highly parallel system, but it's also very client friendly and allowing you to do this end-to-end secure user experience.
Right. Which goes also back to what Alexandra was saying about, the security of the system, right? And
the reading
a major
part,
industry problem as well.
I think once again, so you look at traditional blockchains today. So first, they put all the users in the same chain, and then second, to try to alleviate. So that creates a bottleneck out of the basically like. From day one, there's a bottleneck because all the users are always going to be on the same chain of blocks. Now, in the history of blockchain, people are like, okay, that's fine, but we're going to use very large blocks, and then we're going to tweak the blockchain protocol so that we are there's always going to be a limit on there's going to be a limit on the TPS, on the transactions per second, but we're going to make the limit pretty high.
Right.
Depending on who you talk to, pretty high is like 100 transactions per second, 1,000, 10,000. 100,000, that kind of maybe along the year, depending who you talk to, but there's always a limit. But the problem is that in the process of doing that, optimizing the blockchain for this limit, so the modern blockchain, so they have very large blocks, and then suddenly it's very impossible. It's impossible for normal users to actually follow what's going on the blockchain. You can't just run a full node of Solana. Just to take one example, you cannot just show up and run a full node of Solana. You need dedicated machines. You need a good network. It's not gonna, or even Ethereum. It takes a lot of storage, for instance, to run a full node on Ethereum, and synchronization time. The first time you plug the node, it takes 2 days to synchronize. So that's the problem with when you're not sparse in your data.
Yeah. Alexandra, do you want to say something? Yeah.
I just wanted to add up because Matthew, let me just build on what you said about the TPS. So our pitch was always somehow, there will be a lot of devices, they will all communicate, and a lot of transactions. However, when we've seen it with our own eyes, it was like us, the whole team, were like, no, there is a mistake, and they're like, Alexandra, count again. And so the 80 buses that are now running with the system, we're not writing everything on chain just because we're still learning what is the balance, how much we have to batch and what is what is really needed. Even though in our thesis and vision, we think everything will land on chain in the future. It's like, remember this conversation about the SMS in the beginning of 2000, like who gonna need mobile connectivity, right? Let's do SMS, whatever, $170.
The first time somebody told me that they had a video feed on their phone, I thought that was like the silliest thing I ever heard. I was like, why would you put television in your phone? Like, that's phone is a point-to-point connection. Television is.
What are you gonna do on the toilet otherwise? I don't understand.
No, definitely didn't think about this application in mind.
Right. and so, this thing, we have 1 billion transactions per day.
Per day.
80 buses.
Just for 80 buses?
Yeah.
Yeah.
Oh my God.
Exactly.
Wow.
And it's like for the first set of data points that we're collecting. So, right, if we think of it like real automation, building smart cities, etc. I don't know, guys. We're really gonna need a lot of,
Should
right?
it?
What gets me excited is, again, like you talked about this before, right? Like financial use cases has found some level of product market fit, right? And so people now associate crypto and blockchain specifically with these financial use cases, and now prediction markets being the hot thing still within that category. What gets me excited is like real life solutions to problems, right? And that's what you're addressing here, right? We all know that like smart cities are coming, right? And are already in development, but there are major networking issues here, and you guys are addressing that head on, and it really does feel like Linera's architecture helps to enable that for the future. That gets me very, very excited, right? Like
Exactly. So you have the TPS thing right there, right? So it's not even the question anymore about like, let's compete and talk about some imaginary, whatever every blockchain can achieve. We really have real life, requirements now to serve this infrastructure. And this is, for my eyes, it's much more than I ever thought of even,
I think in the future you should like lead with that billion transactions a day, because I think that the chat was pretty shocked to hear that. We got some emoji reactions to it.
That's about 12,000 transactions per second, right?
Say it again.
That's about 12,000 transactions per second.
12,000 transactions per second. If we're trying to put that on chain, you need an architecture like Linera. All right, we have a few audience questions, and hey chat, guess what? We also have a POAP for today. You've made it through this call, and so we're gonna give you the password for the POAP in just a minute. But first, some questions. This was earlier from Shoop. I have a question. An IoT has always struggled with trust in raw sensor data. With trusted chain, clearly you did a little research, can we prove the full path from sensor to chain, or is an off-chain attestation layer still needed?
This is exactly what we were talking about. That's from our perspective, that's the shortest path, because otherwise you end up again talking about middle components and middle gateways. So we think the cleanest, most secure solution is from sensor to chain. So we also even have solutions at Staex that you can power up kind of as see a sensor, because we cannot run on the sensor directly. We're working on it, but today we fire up a little virtual machine on a gateway that assigns the key to the sensor. For us, it's for now kind of most kind of the closest solution to what we want to have, because we didn't go yet into hardware integration and all this TPM security stuff. But yeah, we think that's the best path how you can solve it, because if you end up assigning these identities or signing in the cloud, you again have this exactly what you said, like raw sensor data that is just being pushed. And actually, it's funny because maybe it's kind of when we think it through, somebody might say, well, who cares? However, there are a lot of like smart city, smart building, smart house applications where people can actually say, well, are you at home or not, right? I think this has been discussed a lot. And there is this like really cool book that's called Blackout, how they, through this like, dummy data actually manipulated the whole energy network in Europe, causing a blackout. And it was written with a lot of experts. So it's actually really, nice reading.
Wait, nonfiction or fiction?
That's that's fiction. But they.
Okay. It's like, did this happen?
This
I mean,
happened.
I know that like Spain lost.
Remember Spain,
You know,
yeah.
I was gonna say.
It's an old book, but just by reading this, actually, it's interesting because they played out a lot of things and they talked to a lot of experts, security experts, energy experts, and how this whole thing is actually very fragile, how you can manipulate it. So even with some dummy data of creating some sort of usage, etc., sending wrong coordinates to robots, right? They can block streets and cause a lot of kind of troubles in the city. Actually, you can already start doing a lot of some shady things even by this, right? So security is kind of still needed at the first place.
Can I ask what your security boundary looks like ideally? Are you going to trust the bus, or do you really want to have like a black box sensor?
So we have our module right now, right? So I mean, in my history, I worked a lot with all the hardware extensions for keys, right? Mm-hmm. That's why we don't do it as a company.
Yeah.
I learned that it's very kind of hard to do it at scale. So our plan today is just by using TPMs. That's the kind of best, we think, combination between usability and security. Right. We also talk, of course, us coming from Deutsche Telekom, maybe looking into SIM cards to kind of use it and all this kind of eSIM embedded modules. But today we just handle it in software right now, so we kind of seal the box, and this is how this is kind of proven today. But there is, for sure a lot of things that we can integrate with, like ARM Trust Zone and all the kind of SGX extensions and all that stuff.
Nice.
We're gonna answer another question here, but while we do, we're 5 minutes left before the top of the hour, so everybody's got to get their password. This is a POAP just for fun, because you were here. We want to say thank you for being here and for listening to this conversation. We're giving away a POAP, a special Staex POAP, and the secret word is microchain level throughput. A lot of letters, but you can type it out. So you can download the app, click on secret word, and mint secret word, and then type that in.
Like
another question.
Choosing words that are difficult to spell. Maybe we could have acknowledgement next time or something like that. Or
don't forget the G in
appointment or.
That's right.
That's like the toughest word to spell.
The throughput is a very hard word, right? But I don't know. If you were able to follow this conversation, then you should be able to spell throughput. That's I think the way that we think about it. Tom had a question here. I think it was also really interesting. Do you find signing to be an issue if this rolls out at massive scale, or is the latency not an issue among real live users? Does anyone complain about latency?
I can take it. So what we do today, we specifically really say this. We work in near real time because there is also like a big definition, like what is it real time for the industry. So what we do today, it's mostly for attestation, certification, like what we said, it's like a notary for things that happened, or like to prove that certain numbers actually exist. It is a topic actually. And what we did at Staex to kind of speed up this communication, we did a lot of research and chosen the most kind of efficient size of the key and the algorithm behind it. So it is a topic. We also use libraries in Rust that have optimized for encryption, because actually we talk about every packet, and it's a topic. And I think, honestly, also coming back to when I was doing my research, right, there is this like funny 400 millisecond latency that IBM made research on, when they said, under 400 millisecond computer makes you dependent and want to crave to interact with the computer. So I believe the more we build smart cities, use cases where the cars take decision, who goes first on the crossing, etc., latency will be like super important, and we're gonna operate in like literally millisecond domain. So every improvement we're doing right now, as Matthew said, on latency, throughput, improvements on the network side, like every step actually will matter. That's my vision for the future.
Cool. If I can add something, so the yeah, I love the vision. So when it comes to verifying signatures, so the connection between devices and the blockchain. So there's one thing that's pretty interesting with Linera is, or could be challenging with other systems, is you may end up, if you, so what most hardware is going to do is your sensor is going to sign the data. So there's the constructor has the any camera does this, but when you take a picture, there's a signature from the hardware. So with essentially a signature you can verify, like maintained by the constructor. And so now the question is, like, when you want to, if you want to link the data coming from the device to the blockchain, so you're going to have to verify the signatures, and that could be a lot of signatures, a lot of computation. If you imagine you have 1 billion signed data to verify every day, so every transaction you got to verify the signature. If you do that on a single, same thing as, so it's kind of magnifying the bottleneck, the contention problem I was mentioning. And one of the aspects of Linera that I think also is very interesting is you would verify, typically you would verify this kind of signature coming from the outside world. You would verify them on the chain of the bus, in this case, on the user chains. So and then after that, you wouldn't have to verify it anywhere in your system. So once you have created a block that inputs the data and verify that the data is correct, then that block can message other parts of the system, and you never need, and you can trust that the data, the signature has been validated. But importantly, you verify the signature on the chain of the device, on the chain that is assigned to the device. And so as a result, you avoid the contention of verifying signatures in a single centralized chain of blocks. Another thing also that is I think interesting in the talking about latency and the vision, in the future vision, is Linera validators in the future, they will be sharded geographically. So we could incentivize our validators to have a data center in a particular region, even maybe some cities could have
in a bus piece that's moving around.
No.
Really?
We're not going to put validators in the bus. No, not that. But in the city next to the bus, there could be a machine operated by many of the Linera validators, meaning that the chain of the bus actually lives in the same city as the bus, for instance, or at least the same region. Meaning that when the bus wants to create a block, it needs to talk to all the validators, but it's going to talk to the kind of the local antenna, the local shop of each validator, meaning that you don't have to pay a round trip around the world to create a block in the bus chain, right? I thought that was something worth mentioning, because it shows like this design with the many parallel chains can really go a long way. And once you realize that, okay, you have a parallel system, then, oh, wow, maybe parts of this system could be actually geographically attached to a particular region. And we get that for free. Like, the theory is there's nothing to change. The protocol is already there. It's super easy.
And this is super needed. And also, I remember we were doing some research. Just the network round trip in Germany alone is like 40 milliseconds. And again, if we talk about everything being added up, it's a huge saving that we have. And also, data ownership is like super essential for every city, I guess.
Yeah. Well, we have reached our hour. There was people are very interested in this book that you mentioned. I think I found it. Is this, wait, let me find it here. Is this the book you're talking about?
Yes, exactly.
Okay, cool. So it's called Blackout by Mark Ellsberg. If you're curious, I'm definitely curious. I want to download this book. I want to hear it. A techno thriller. That's basically my exact genre, techno thriller. You just nailed me, Alexandra, perfectly. So this has been so much fun. Thank you so much for telling us in detail what you guys are doing. I think somebody from the team is going to be on Community Hour as well this Thursday. So more people will be able to hear a little bit about what we're building. And now I have a much deeper knowledge of it from this conversation. So that's awesome. Really, really cool. We are really, really, really proud to have you guys as a partner with Linera. And thank you so much for spending this hour with us and explaining everything that you guys are building. And Sergey, do you have anything to say? We didn't hear your voice at all. Hello.
No, I don't anything to add. Alexander.
Well, it was wonderful. Thank you guys so much for being here, and have a wonderful evening.
Thank you so much.
Everybody. Thank you.
Thanks, everyone. Bye.
I mean, everything is just too slow, and we need to adapt. And that's kind of ridiculous, right? We live in a real-time world.
And I think that's the way that we need to move now.